This is the last section we're going to do in the chapter, and we're going to be looking at the graphs of the other four trig functions. We'll start with tangent, we'll move into cotangent, and then we'll move into secant and cosecant. What you need to understand, particularly about tangent and cotangent, is that I need you to recognize the differences and similarities between them and be able to identify which graphs are tangent and which are cotangent. When we get to secant and cosecant, because they are related to sine and cosine graphs, you will be expected to understand how those change with the transformations. To start with the graph of tangent, let's take a look at what happens to tangent over the course of the unit circle. So at 0 radians, tangent, remember, is y over x, so it's 0. At pi over 2, we're up here, and it's 1 over 0. 1 over 0 is undefined. Then, as we move around to pi radians, again, it's 0 over negative 1. So that's just 0. And then as we rotate down here, again, it would be negative 1 over 0. Anything over 0 is undefined. And then finally back at 2 pi, we're at 0. The vocabulary term you have for this particular section is an asymptote. An asymptote occurs in a location where graphs are undefined. So I will draw my asymptotes in blue. We've got one here at pi over 2. We have one here at 3 pi over 2. We'll have another one at 5 pi over 2, one at 7 pi over 2. As we move backwards, we'll have one here, one here. Now, the other components we know are the zeros. We have one here, there's one here, one here, one here, and then as we move backwards. So the question becomes, what happens in between the asymptotes? So what I'll do is I will start here at 0, and I'll remember the fact that tangent is really the slope of the line from the origin to the edge of the point. So this slope is getting increasingly larger until I get to this undefined slope. So it's doing this. Then it'll get increasingly smaller until it hits 0 again. If I go backwards, this slope is negative, and it gets increasingly more negative until it's undefined. So that looks like this. And that pattern will continue to repeat itself. The period on this graph, meaning where does it start to repeat itself, is pi. Because once we're down in this quadrant, it's going to be the same values as when we were up in this quadrant. So the period is pi units. We'll take a look at cotangent in the same way, from 0 to 2 pi. Now we'll remember that cotangent is x over y. So at 0 radians, it's 1 over 0. So that's where it's undefined. At pi over 2, it's 0 over 1, which is 0. Then at pi, it's negative 1 over 0. That's again undefined. At 3 pi over 2, 0 over negative 1 is 0. And then at 2 pi, 1 over 0 is again undefined. So these locations where it is undefined, again, we have asymptotes. So there's an asymptote at 0. There's an asymptote at pi, at 2 pi, 3 pi, and then going backwards at negative pi, at negative 2 pi. So that means at pi over 2, we're crossing the x-axis. At 3 pi over 2, 5 pi over 2, 7 pi over 2, moving backwards, negative pi over 2, negative 3 pi over 2. Then, when I look at these values, instead of thinking about the slope of this line, I'm going to start thinking about the slope of this line. So this is undefined. This slope is much steeper, and as I progressively move, these slopes get flatter and flatter. So what ends up happening is this. Obviously, this looks a lot like tangent. So some key differences that you have to pay attention to. Cotangent has asymptote at the y-axis. Tangent actually crosses the origin. With tangent, as the radians increase positively, the slopes increase positively. With cotangent, as the radians increase, the slopes actually decrease. When you think about the graph of secant, what I actually want you to do first is consider the graph of cosine. We know the pattern on the cosine graph. And we can easily plot those points. Now, when we start to plot secant, we need to start thinking reciprocal of cosine. Well, reciprocal of cosine, that's simple enough, that's 1. Reciprocal of 0 is 1 over 0, which we know is undefined. And what happens when things are undefined? We get an asymptote. Reciprocal of negative 1, simple enough. Reciprocal of 0, again, is undefined. That means there's another asymptote. Reciprocal of 1, that's 1. So what you should notice is that every time cosine crosses the x-axis, secant has an asymptote. But whenever cosine has a minimum or maximum, those secant values are the same. So I'll put in my asymptote here, I'll put in one here, and I'll put in one here. So the question is, what happens at these minimums and maximums? Well, it's a reciprocal. So where cosine has a maximum, secant has a minimum. The beautiful thing about this is that as cosine changes, so whether it changes in amplitude, or if there's a vertical shift or a horizontal shift, secant is going to change identically to cosine. When you click on the links for the graphs, you should pay attention to the way that happens because you are responsible for being able to graph secant with amplitude, with period change, with phase shift, with vertical shift. Our final graph is cosecant, and again, I want you to think about the reciprocal of cosecant, which is sine. We know the pattern on sine, and we can very easily plot this graph. So as we begin to plot cosecant, those same rules are going to apply. The reciprocal of 0 is undefined. That means there's an asymptote. The reciprocal of 1 is 1. The reciprocal of 0 is undefined. The reciprocal of -1 is -1. The reciprocal of 0 is undefined. So every time that sine crosses the x-axis, cosecant is going to have an asymptote. The values on the max and min will be the same values. Only every time sine has a maximum, cosecant will have a minimum. Every time sine has a minimum, cosecant will have a maximum. So again, you are responsible for understanding the relationship between cosecant and sine. You are responsible to know that if sine has a change in amplitude, that's going to change the location of cosecant. Make sure that you check out the graphs that I've given you links for and that you play around with them a little bit because you are responsible for being able to do this. As I have put in Canvas, I will not be in class on Monday. You are still having a test on Wednesday. Make sure you understand these concepts and come see me on Tuesday if you do not.